previous co-op was at a biotech startup working with microfluidics, or really tiny droplets. So we would have different chemical compounds encased in these droplets, and then they would also be mixed with a dye. These droplets were then shot at several other droplets that contained SARS compounds, and this final mega droplet would look dark if the SARS was inhibited and fluoresce if it wasn't. So this first machine here was used to make sure that the dye was uniform and that our emulsion was creating drops that weren't broken. It was just a 2-axis, very simple, 2 degree of freedom type of machine, and it was really fun to build. And the second one, it's sped up, but it's a fraction collector, so what it would do is it would take the sorted drops. One side would be dark, one side would be light, as determined by a PMT or just like a very high-powered laser, would go down, dispense, and once it decided that it was full, it would move on to the next tube. So these were some of the introductory projects I did while I was at my previous co-op. I show these machines not as a way to flex, but a way to show that mechanical engineers actually have a lot of versatility when it comes to different industries. So right now, I'm working at my battery co-op and I'm doing a lot of machine shop work, and at my previous co-op, which was very bio-focused and full of chemists and biochemists and wet lab work, I was still able to be useful even though I didn't have a lot of knowledge about things like that, cell culturing, proper clean room etiquette. So if we take a look at the ASME, the American Society of Mechanical Engineers official website, we can see what mechanical engineers are up to right now. So it looks like there's some stuff on fuel cells, so that's about stored energy, robots built from human tissue, some more biomedical applications, stealth technology, so you can go into defense. There's some stuff about material development, so that's kind of like material science, large scientific instruments. Honestly, that could apply to anything. 3D mesh wearables, so this can be used for bioinformatics or just general like health science applications. An armory, kind of self-explanatory. Polar bears for some environmental science. More energy stuff. Energy is pretty big right now in mechanical engineering. Nanoscale trapping proteins. So this is some more bio stuff. Heat pumps, classic mechanical engineering. That's something that's covered in thermodynamics. Food, sustainable living. NASA, aerospace, which is expected. More energy, some sustainability stuff with this robot with microplastics. Computing stuff. Material development. And this is probably more of like a bio health type of thing. As you can see, there's a lot of flexibility within mechanical engineering as a whole. I hope this video series has helped you with your major selection and has alleviated some of your fears. Best of luck!